Well, welcome. In this video, we are going to be finding the kernel, the maximum and the minimum of a given function. So let's f of x be the function equals to 2/3 of x cubed plus 3x squared plus 4x. What we want to do here is to find the kernel of x and then compute its minimum and maximum. First of all, we're going to take the kernel, and to do that, we're going to first set the function f of x equals to 0. Then we're going to factor x to obtain a product with, on the one hand, x equals to 0, and on the other hand, 2/3 of x squared plus 3x plus 4 equals to 0, which we are going to solve using the PQ formula or whatever formula you might know. And of course, making sure that the coefficient of x squared is equal to 1. By using the PQ formula, we're going to assume P equals 9.5 and Q equals to 6. And by using the general solution, x sub 1 or 2 equals to minus P divided by 2 plus minus the square root of P over 2 squared minus Q. And by replacing P and Q with their value in the general solution, we will obtain x sub 1 and 2 equals to 9.5 divided by 2 plus minus the square root of 9.5 divided by 2 squared minus 6. Then we'll be given two solutions, x sub 1 and x sub 2, that are both negative rather than less than 0. What means in this case that there is no solution, and therefore we will decide x equals to 0 be the kernel of this function. Now we want to compute both the minimum and the maximum of f. And the first thing we want to do here is to take the first derivative of f prior to x, which is equal to 2/3 times 3x squared plus 6x plus 4, and together 2x squared plus 6x plus 4. Secondly, we will work out the derivative equals to 0 using the PQ formula. Then we're going to divide the whole equation by 2 to make sure the coefficient of x squared is equal to 1, and identify p equals to 3 and q equals to 2. Now, by plugging p and q in the general solution, we're going to have x sub 1 or 2 equals to minus 3.5 plus minus the square root of 3.5 squared minus 2. What is going to give us two solutions? x1 equals to minus 1 and x2 equals to minus 2. At this point, we know that we have a minimum and a maximum, but we don't know yet which one is minimum and which is maximum. And to compute the difference between the 2 points, we need to take a second derivative, which is 4x plus 6. And now we're going to plug x1 and x2 respectively in the second derivative to see what is coming out. For the first one, second derivative of f of minus 1, we are having 2, which is bigger than 0, and it means that there is a maximum at x sub 1 equals to minus 1. And for the second derivative of minus 2, we're going to have minus 2, which is less than 0, and this means that there is a maximum at x sub 2 equals to minus 2. We can also find the y's of that points by plugging x1 and x2 respectively in the original function. For x1, we're going to have minus 5/3, and for f minus 2, we're going to have minus 4/3. Therefore, we can conclude that there is a minimum at the point minus 1 and minus 5/3, and a maximum at the point minus 2 and minus 4/3. Alright, thank you for watching again. Take care.